and welcome to Digital Signal Processing online lecture series. Myself Rima Raval from LG Institute of Engineering and Technology. In today's session, we are going to see the topic Linear Convolution from the unit number 2, Discrete Time Signals and System. Now in previous session, we have seen the linear convolution, its formulas and its methods, and we have studied the two methods of linear convolution. Now in this session, we are going to consider the examples for the third method. So let's start with that. Now let us revise the linear convolution formula. The linear convolution formula is given as output convolution sequence y of n that is equals to summation of k equals to minus infinite to infinite x of k into h of n minus k. Okay, so this is the linear convolution formula that we are using. Now the methods of computing linear convolution are mathematical method, graphical method and tabulation method. We have seen the mathematical method and tabulation method in previous sessions. Now in this session we are going to consider the third one, graphical method. So third, graphical method. As the name suggests, in graphical method we need to plot the graphs of the given data sequences, and according to that we will obtain the output convolution sequence or else output sequence y of n. So now let us consider one example. In which data is given as x of n that is equals to 1, 1, 1 and h of n equals to 1, 0, 1. Okay, in both of this input sequence and impulse response of the function, the arrow is at the first position, that means at the first value. Okay, so now let's see how the graphical method goes. So first of all, we know that to define the mathematical formula we need to define the range of n and we need to define the range of k, right? So first let's define the range of n. For that we need to define the higher range and lower range. So for higher range we will need to have the higher value of x of n and the higher value of h of n, right? So here as you can see, this indicates 0 position, first, second. Similarly in h of n this indicates 0 position, 1 and 2. So for this higher range is what? X of n 2 plus for h of n the higher range is also 2. So our higher range for n will be 4, right? Now let us define the lower range, for which we need to see the lower range for x of n and lower range for h of n. So for x of n the lower range is 0 and for h of n it is also 0. So it will be 0, right? So we can say that range of n that will be equals to 0 to 4, right? So here lower range is 0 and higher range is 4. Now we need to define the range of k. So we know that the range of k depends on the range of x of n strictly. So x of n range is 0 to 2. So range of k will be 0 to 2. Okay. So thus we have defined the range of n and k. Now we will use the mathematical formula to plot the graphs and then according to that we will find its values. Okay. So first of all, let us see the mathematical formula which we have seen earlier, that is y of n equals to summation of k equals to minus infinite to infinite x of k into h of n minus k, right? So for that now we will place the range of n that is equals to 0 to 4 and we will take k's range 0 to 2. Okay, with the values x of n 1, 1, 1 and h of n 1, 0, 1. Okay. So here x of n is 1, 1, 1 and h of n equals to 1, 0, 1. And we are finding for the value n equals to 0, that will give you y of 0, that is equals to summation of k equals to 0 to 2, right? X of k into h of n minus k, but n over here is 0, so this will give h of minus k. Now if we have to solve this using mathematical formula, we will place the values of k in this formula and we will add the values of that, right? But here this is graphical method, so we need to plot the graph of x of k and h of minus k, and then we need to multiply the respective values, right? So let us plot first of all x of k according to the given x of n, right, for the instant k. So the graph of x of k versus k will be like this. For here, this indicates the position 0 where the value is 1, right? So over here, we need to indicate the value 1 for 0 position. Then for the position 1, the value is 1. So this will be again 1. Then for position 2, again the value is 0. So here it will be 0. So this is how we have plotted the x of k according to x of n, right? So from this we can obtain the x of minus k or else x of plus k plus 1 or whatever it is. And now we need to multiply this x of k with h of minus k. So first of all, let us draw h of k according to the given value h of n, right? So this is h of minus k versus k. This is the 0 position where the value is 1. Then for position 1 the value is 0, and in position 2 the value is again 1. So it will be like this. So this is not h of minus k, this is h of plus k, right? Because we have plotted the sequence exactly according to the given h of n. Now from this, using folding operation, we can obtain the h of minus k. So it will be like this, h of minus k from h of plus k. These all the sequences are folded on the left side. So now this instance will be in negative side and this will at the same position. So at 0 position there will be the value 1. This 1 will go on the left side on the minus 1 position having the value 0. This 2 will shift to the minus 2 side where the value is 1. Okay, so this is the folded sequence of this h of k. It is h of plus k, right? Now we need to multiply x of k into h of minus k. So with the respective elements of x of k and h of minus k, we will get the value of y of 0, right? So as you can see over here, y of 0 will be equals to elements multiplication. That means at instant 0 the value of x of k is 1 into at that particular instant the value of h of minus k is also 1, right? So this will give 1 into 1 plus, now here in x of k at instant 1 the value is 1, but in h of minus k at instant 1 there is no value, so we are not considering that, or else we can call it as 0. Now in the instant 2, here it is 1, but here at instant 2 there is no value, so we can take it at 0 or else we can neglect that. Similarly in h of minus k, at minus 1 instant it has value 0, here at minus 1 there is no value. Similarly here at minus 2 the value is 1, but here at minus 2 there is no value. So now the all values, other values are 0, which will give the value y of 0, that is equals to 1. Okay, similarly now we are expanding the values from n equals to 1. Okay, so next for the same data, that means x of n equals to 1 1 1 and h of n equals to 1 0 1. Let us take now n equals to 1. Okay, so for that it will be y of 1, that is equals to summation of k equals to 0 to 2 x of k into h of n minus k, that is 1 minus k, right? Now I can call this as h of minus k plus 1. right? So I will use to represent this like this. Okay, so now let us obtain that sequences and draw it graphically. So we know that x of k is like this, 1 1 1. Okay, so this is giving the value like this, 0 1 and 2 for x of k. And we know that h of minus k is the folded version for that, and for that we are going to make it advanced because here it is minus k plus 1. So minus k was like this, that means this folded sequence, plus 1, that means now the sequence will move to the right side by 1 bit position. That means now the instant 0 will move to the 1, this minus 1 will move to the 0, and this minus 2 will move to the minus 1 value. Okay, so now according to this, let us plot h of minus k plus 1, or else you can say 1 minus k, right? So this is h of minus k plus 1. So here the value, that means 0 value will be at plus 1 and that value is 1. Now at 0 the value will be 0, and now at minus 1 the value will be 1. So as you can see, these are shifted to the right side because of the plus 1. Okay, now we need to multiply the respective values, which will give you the y of 1. Okay, so here to obtain y of 1, that is equals to multiplying the instant minus 1. Here minus 1 have 1 value, but here at minus 1 instant there is no value, so we are neglecting this, or else we can take it as 0. Here at 0 instant the value is 1, and here at 0 instant at value is also 1. So this will be 1 into 1 plus here at instant 1 the value is 1, and here at instant 1 the value is also 1. So this will be again 1 into 1. So we are multiplying the respective discrete values according to the discrete time instant. Now here at instant 2 the value is 1, but here at instant 2 the value is 0. So we are not considering that. So by this we are getting the value y of 1, that is equals to 2. Okay. Similarly, now we are finding the value for the next n equals to 2. Okay. So now for the next, that is n equals to 2, we will have the same values, that is x of n equals to 1 1 1 and h of n equals to 1 0 1. So now according to the formula we will get y of 2, that is equals to k equals to 0 to 2 x of k into h of n minus k, that is 2 minus k, which gives what? H of minus k plus 2. That means you can shift the signal by 1 in the h of minus k plus 1, or else you can shift the signal by 2 instant on the right side. That means by adding that 2 samples in h of minus k, right? So now let us plot that. So here it is h of minus k plus 2 versus k. So as you can see in the previous one, h of minus k plus 1 was having the instant minus 1 0 1. Now it will shift by 1 on the right side. Okay, so this minus 1 will be at 0, this 0 value will be at 1 instant, and this 1 instant will be at 2 instant. Okay, so here we will have the values at the instant 0 1 and 2, right? So at the 0 instant the value will be 1, at 1 instant the value will be 0, at instant 2 the value will be again 1. So this indicates the h of minus k plus 2 value. Alright, now we need to multiply it with x of k, which is given as 1 1 1. So here this is 1, this is 1, and this is also 1. So at 0 position the value is 1, at 1 the value is 1, at instant 2 it is also 1, right? So now to obtain the output value y of 2, we will multiply the respective values at the particular instant. So as you can see, at instant 0 h of minus k plus 2 have the value 1, at instant 0 x of k is also 1, So by multiplying the respective values, we will get 1 into 0 plus 1 into 1. So y of 2 will be equals to 2. Okay. So now we have find the values of n equals to 0, n equals to 1 and n equals to 2. Now we are ending this session here only, and in the next session we will continue this example from the instant n equals to 3 and n equals to 4 using the graphical method, and we will obtain the final output sequence y of n indicating its 0 position. Okay. These are the references. Thank you. Thank you for listening, and we will continue this in the next lecture. Thank you.